Off, right?
Yep, you are
Yep.
good to go.
Okay. So, hi all. As My name is Farali, and I've started working as a GST with the University Academic Success Program. So today I'm going to walk you through the statistical concepts review, the basic statistic concepts which we use. So yes, let's get started. So today we'll cover these points, basic points like what is sample versus population, the types of data which are being used in statistics, the types of data distribution, the very important central limit theorem, which you will come across many times while solving the statistics problems. What is the law of large numbers? What are large numbers? Then why do you need large numbers? And then the basic overview of what is our Graduate Academic Support Center. Okay, so let's get started. So basic definition of what is sample and what is population. So what is a sample? A population data set contains all members of a specified group. So this is nothing but your population. So example is a population may be all people living in the US. So you can consider population as your main set, like the one which is given here. And what is your sample? A sample data set, it contains a part or a subset of a population. Example, the sample may be some people living in the US. So you can say that US is the population and sample is nothing but your Arizona state, right? So this is nothing but your sample and population. Sample is a broader view, and sample is a part of it, a subset of it. Um, next, next is okay. Then, what is sample mean versus the population mean? So, what is mean? Mean is nothing but the average of all the values in that subset divided by the total number of values in that subset, right? So, say suppose in case of population example, the size of population n equal to 30. That is, you have got say 30 students in the class, and say uh, you are told to find the average, the mean of the class. So, and the marks, say suppose you have been told that the marks of all the students in the class is 300, and there are total students 30. So how will you find the mean? So the mean is nothing but the sum of all values in the class divided by the total number of students. So in our example, it is nothing but say 300 upon 30, which is 10. So that is nothing but your population mean. Okay, now if I want to give you an example of what is the sample mean, say suppose you're told that out of the 30 students, find the mean of boys, and you have been told that out of 30 students, 10 students are boys, and their sum of all the boys, sum of the marks of all the boys is 100. So how will you find the sample mean? The sample mean will be nothing but the sum of the marks of the boys, which is 100, divided by the total number of boys, which is 10, right? So your mean will be 10. So this is nothing but population mean versus sample mean. Next, an example is given. A teacher wants to find the average score for a student in his class. The teacher's sample set has 7 different test scores: 78, 89, 93, 95, 88, 78, and 95. And here the population is the scores of the entire class, whereas the sample is the set of even scores, 7 scores, right? So like what example I gave you, the same example is shown here. The population is nothing but when the entire class is taken into consideration. The sample will be a part of this population. Next, diving into the very important concept of standard deviation. What is standard deviation? So, standard deviation is the measure of the dispersion of the data in relation to the mean. So, mean is nothing but the central value in our data set, and the standard deviation, it tells you how far the other values are from the mean. So, the standard deviation is the average amount of variability in your data set. It tells you on average how far each value lies from the mean, the central value. A high standard deviation means that values are generally far from the mean, while a low standard deviation indicates that values are clustered close to the mean. So, in any date in a given data set, you would always want your standard deviation to be as low as possible. A low standard deviation means that all your data is clustered about your mean. Okay, so yeah, the closest to zero the standard deviation is, the more close to the mean the values in the studied data set are. So ideally, your standard deviation should be as low as possible. Then, what is standard error? So there will be different means for different samples from the same population. This is called a sampling distribution of the mean. So the standard error is very similar to the standard deviation what we just saw. Both are measures of the spread of the data around your mean. The higher the number, the more spread out your data is. So again, the standard error is the variance between the means of different samples, and it is denoted by the standard deviation of this sampling distribution. So how do you calculate the standard error? Your standard error is nothing but your standard deviation by the square root of the sample size. That will give you your standard error. So standard deviation and standard error, they both go hand in hand. Now, a very important concept of types of data. There are you would, while solving the statistical problems, you will come under different types of data. Okay, so basically the data is classified into two main types. The first being the categorical or the descriptive data, and the second one is the numerical data. Now, what is the categorical data? The categorical or the descriptive data, as the name suggests, that is the data wherein the data set is defined by a summary, a description. Okay, and then what is the numerical data? In the numerical data, you'll again have two parts. One is the discrete and one is continuous. Discrete data is the one which is having proper margins between them. And like, for example, when you plot your discrete data, you can visualize it through a bar graph. Okay, so bar graph is how you would plot your discrete data. So as in a bar graph, your margins are specified. Okay, and continuous data is the one wherein the margins aren't clearly specified. So if you would want to imagine your continuous data, you would plot it using a histogram or a line graph. So as you know, in a line graph, the margins aren't well defined. So that is how you would uh, display your continuous data. Then the types of data distribution. How you can distribute your data? Once we know the type of data, how are you going to distribute the data? So there are different types of data distribution, uh, but we'll go through all these in brief. The first one being the Bernoulli distribution, then the uniform distribution, binomial distribution, normal distribution, then the Poisson, and then the exponential distribution. So let's get started with the Bernoulli distribution. So what is the Bernoulli distribution? It is a discrete probability distribution for a Bernoulli trial, which is a random experiment that has only two outcomes. That is usually called a success or a failure. So, so given a random variable x, which has a Bernoulli distribution, and it can take value 1 with the probability of success, say p, and a value 0 with the probability of failure, say q. So q can also be, the failure rate can also be found out by 1 minus success rate. So the best example to explain what Bernoulli distribution is to toss a coin. So here the occurrence of a head denotes success and the occurrence of a tail, say, denotes failure. So this is nothing but like how the Bernoulli distribution can be plotted. So Bernoulli distribution has either 0 or 1 values. And the Bernoulli distribution just takes one instance, one experiment into consideration. So this is the formula, the expected value of the how to find the expected value of the Bernoulli distribution. P is nothing but your success rate, and 1 minus P is nothing but your failure rate. This is the variance. This is the formula for variance. The next distribution is the uniform distribution. This is the most commonly used uh, distribution along with the normal distribution in reviewing in the statistics concepts. So what is a uniform distribution? Say suppose a random variable x has been given any number of outcomes, and all the outcomes have got equal probability. So as the name suggests, uniform distribution, in the uniform distribution, all the random variables will have the same probability. The best example is rolling a die. In this case, there can be six outcomes: one, two, three, four, five, six, and each of them will have the same probability, right? That is 1 by 6. So in statistics, distribution function in which every possible result is equally likely, that is, the probability of each occurring event is the same, can be plotted using the uniform distribution. The data is uniformly distributed. So in uniform distribution, you can find the expected value by taking A and B are nothing but the lower and the higher value range. So A is your lower value limit, B is your higher value limit. And the variance can be found out by the upper minus the lower bound square divided by the number of outcomes. The next is the binomial distribution, again, an important one. So, a binomial distribution is a distribution where only two outcomes are possible, as the name suggests, bi. Okay, such as success or failure, gain or loss, win or lose, and where the probability of success and failure is same for all the trials is called as a binomial distribution. So, this is the same with Bernoulli distribution. The difference being in Bernoulli distribution, only one experiment or only one experiment is taken into consideration, whereas in the binomial distribution, multiple experiments or events are taken into consideration. Uh, the binomial is a type of distribution that has again two possible outcomes. The prefix bi means two or twice. Example, an experiment with only two possible outcomes repeated n number of times is called as binomial, such as tossing a coin. So this n is very important here. We are performing the same experiment n number of times. The expected value can be found out by the number of times the event is being performed into the P is the success rate. The variance can be found out by the number of times the experiment is repeated into the success rate, and Q is your failure rate. Q can also be found out by 1 minus the success rate. The next one is the normal distribution, a very important one. So any distribution is known as normal distribution if it satisfies the following criteria. Uh, the criterias being the mean, median, and mode of the distribution coincide. So mean is nothing but the average of all the values divided by the total number of outcomes. The median is your central value in the data set, and the mode is the number or the data which occurs maximum number of time, whose frequency is maximum. That is nothing but your mode. So in an ideal normal distribution, all these three values, they coincide. The curve of the distribution is bell-shaped and symmetrical about the line x equal to sigma. So this one, you can see this is a bell-shaped. So this is nothing but a normally distributed. If you draw a central line, that will be nothing but your line of symmetry, as we call. The total area under the curve is ideally 1. Exactly half of the values are to the left of the center and other half to the right. So your line of symmetry, it divides the entire the normal distribution into two halves, one at the left side, one at the right side, both exponentially decreasing. Okay, the next one is your Poisson distribution. So a Poisson distribution is a one that is used to show how many times an event is likely to occur over a specified period. Okay, So, a Poisson distributions are often used to understand independent events that occur at a constant rate within a given interval of time. So, it is applicable in situations where events occur at random points of time and space, wherein our interest lies only in the number of occurrences of the event. Can see a Q&A. Yes, by coincide, do you mean yes, it should be the same, it should lie on the same line. So, yes, the same value, equal. Okay, so the best example of Poisson distribution is say, suppose in a cafe, the customer arrives at a mean rate of 2 minutes, 2 per minute. Find the probability of arrival of 5 customers in 1 minute using the Poisson distribution formula. So in here, you can see that you're told to find the number of occurrences over a given period of time. So such type of problems can be plotted or visualized using the Poisson distribution. One more example being the number of emergency calls recorded at a hospital in a day, or the number of thefts reported in an area on a day. So these such situations or such instances can be plotted using the Poisson distribution. The next and the last one which we are going through is the exponential distribution. So what is an exponential distribution? It is a continuous distribution that is commonly used to measure the expected time for an event to occur. So exponential distribution models the interval of time between the events and also for survival analysis. So basically, it is the time span. It basically calculates the time span between two events. Example, the length of time between the metro arrivals or the length of time between the arrivals at a gas station, life of an air conditioner. So all these probabilities like the can be calculated using the exponential distribution formula. So, for example, the amount of time beginning now until an earthquake occurs has an exponential distribution. So, like if we know that the current time or the previous time of when the earthquake has occurred, we can predict or we can find the probability of when the next earthquake might occur using the exponential distribution. So, other examples again include the length of time in minutes or the long distance business telephone calls and the amount of time in months, or how long can a car battery exist. So all these probabilities can be found using the exponential distribution. The next one is your central limit theorem. So what is a central limit theorem? The central limit theorem states that if you have a population, example with a mean mu and the standard deviation sigma, and take sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. So what does this mean? So it states that if the underlying distribution is not wildly non-normal, the average from the random samples of sufficient sample size n will be approximately normal too. It means that even if you have a population with a very large amount in a very large quantity, still the mean will be centrally located. In the bell-shaped graph, it will be centrally located. Uh, the standard error of the averages again will be proportional to the standard deviation of the underlying distribution. Note, when you consider when you want to find the central limit theorem, the samples must be independent. Now, what do you mean by independent samples? Independent samples are the samples that are selected randomly, so that its observations they do not depend on the values other do not depend on the other values of further observation. So this is the central limit theorem. To brief out the central limit theorem, it means even if you have got a very high or very large data set with high values, still the mean will be centrally located and that you can plot it using the normal distribution. So this is how your normal distribution will look like. The central limit theorem example. So a very important concept that is the law of large numbers. So, what are large numbers basically? And why do you need them? So, the average of random sample of sufficient sample size n will approximate the population mean mu, right? So this is nothing but like the central limit theorem which we saw. It basically means that even if you have got you have got extremely large data set or large numbers in this case, the mean will be centrally located, or it will be the numbers will again be close to the average. So it states that the law of large numbers in probability and statistics states that as a sample size grows, its mean gets closer to the average. So, in the financial or in the statistics context, you can say that the law of large number indicates that a large entity which is growing rapidly cannot maintain that growth pace forever. It cannot maintain that growth pace forever means that after some time, the values again will be closer to the mean values. So, the example being uh, yeah, the example being the underlying data has a mean of 80 and a standard deviation 10, and the average of a sample of 25 such cases has again mean 80 and standard error of 10 divided by the number of such cases 25, which is 2. Okay, so it means that as even though if you increase your data set, the average is going to be closer to the average is going to remain constant over a period of time. So what are large numbers basically? So in a number system, the numbers which are or extraordinarily bigger or greater than the other numbers are called as large numbers. For example, say 1 lakh, 1 million, 1 billion, etc. So these are the numbers which we do not use in our daily life, and that's what large numbers mean. Uh, yeah, that's it. So these are a few slides which uh, have details about the university academic success programs. I think Jesse will guide you through this. Uh,
Yeah,
yeah.
Swirly, if you wouldn't mind going back up to where it says that Grad Academic Support Center at the
Oh no.
bottom. Yep,
Yep.
first line. Yeah, so I'll take you guys through just some information about the Grad Academic Support Center. Just so you guys are aware is that we don't just provide statistics tutoring, we also have writing tutoring for grad students, and these are open to grad students at any level. So that includes anyone with a master's degree, doctoral students, postdocs, and then faculty and staff as well. And then Swarali, I'll have you go to the next slide.
Uh, yep. Graduate
Yep.
tutoring, right?
And grad tutoring. So all of that is with one-on-one appointments. And writing tutoring covers the option to meet with a tutor. You can discuss course papers, any applied projects, theses, dissertations, really any writing project, and you can discuss feedback at any stage of the writing process. They're really great at helping with citations or really anything that comes up during that writing process. And then statistics tutoring is very similar but different. You can meet with a tutor to discuss coursework, applied projects, or research projects. And then all of our tutors are also well versed in statistical concepts. So I'm guessing if you're coming to statistical concepts part 1 and you have more questions, we do have part 2 next week, but then you're also more than welcome and highly encouraged to book a one-on-one appointment. You can get maybe any questions that you have after this presentation answered more in depth through one of our tutoring appointments. And Swarali, if you'll proceed to the next
Yep.
slide,
Yep.
and I'll talk a little bit about the logistics. So all of our grad tutoring is offered solely online. It is one-on-one and it's with a peer tutor, so it's someone that is also in a graduate program. They're all 50-minute appointments and live via Zoom. Our hours are all in Arizona time, Monday through Thursday, 10 a.m. to 9 p.m., Friday, 10 a.m. to 3 p.m., and then Sunday, 5 to 9. And then we highly encourage that you do book appointments a couple of weeks out, especially as the semester goes on. Those appointments do fill up fast, so same for grad writing. That when you are booking appointments, you do kind of keep that in mind. So especially if you might think you might not need an appointment, we urge you to book one now, kind of have that on the calendar and plan out a couple weeks out in advance. And then if you proceed to the next
Yep.
slide, we also have other graduate support options that involve these online grad workshops. They don't just cover statistics topics. Hopefully you've all had some emails on writing topics as well. And those cover kind of a variety of writing topics. I know, at least off the top of my head, our next stats one is that stats concept part 2. And then we have intro to R and intro to SPSS. Those are presented also through Zoom. And then we have summer graduate writing camps. Those cover success in grad writing. And then if you're at the level that you are pursuing your PhD, then there is the dissertation writing camp over the summer, and it's kind of intensive, like 1-week programs to give you time to write or various workshops. And if you need more information, easiest way to get there is tutoring.asu.edu/graduate. And that kind of has all our information on how to book appointments and find out about our other services. All that being said, ways to contact us, if you'll go to the next slide. Best place to start is at our website, so tutoring.asu.edu. And then if you're specifically looking for just graduate resources, tutoring.asu.edu/graduate. We are on social media. Those aren't checked quite as often, but that is a way to check. But definitely that website, and then also our phone number gets you routed to our front desk, which has many helpful people that can help you schedule an appointment or possibly answer any questions you might have. And yeah, that's about it. For Raleigh, if you'll proceed to the next slide,
Yes.
and go ahead and stop our recording.